All right, on this video we've got, we'll start with question 3. We've got a little bit more complicated algebra, but not really. It's still trig, it's still algebra. We just have to do a few more extra steps. So in question 3 here, again, we always read the entire problem, try and picture in our head what it looks like, then make sure we know what our end goal is, right? So find the height of the smokestack right there. That's our goal. So always keeping that in mind, making sure that that's what we answer in the end. Then we move on to trying to draw this picture. So if I try to draw a picture of, what if I do that? That's not going to look very good. Draw a little bit shorter. So here's our building, and here's our little smokestack on top. Very detailed, I know. So you're given that there is a point 200 feet from the base of the building, so out here 200 feet. You have two angles of elevation, one to the bottom of the smokestack, one to the top. So we've got kind of triangle 1 right here, and that would be the smaller angle, so 35. And then there's another angle of elevation all the way to the top. That angle, big angle here, that's 53 degrees. Now it's just saying find the height of the smokestack. So really what we have is two different triangles. We have triangle 1 and we could find, I'm going to label the vertical side of this, the letter T, and nope, wait, 35 degrees. I'm going to label that one not T, I'm labeling that one B. B for bottom, so that's going to give us the height from the ground to the bottom of the smokestack. I'm also going to have another triangle here. And we'll call that one T. That's going to represent the top of the smokestack. So if we find B and we find T, what we're really finding is from the ground to the top of the smokestack, if I subtract from the ground to the bottom of the smokestack, what I'm left with is the height of the smokestack. So we're going to say that we have tangent as our ratio because we have opposite and adjacent sides. So I'm going to just write it out. Tan. If we want to find B by itself, we multiply both sides by 200. So 200 tangent of 35 is B. And the same thing is going to go when we look for the tangent of 53. That ratio is T over 200. So 200 tan 53 is what T is. So if we just run those two numbers, we find, let's see, B. So B, if we run that, we get 140. And I did try to keep that rounded to the nearest hundredth of a unit, in this case a hundredth of a foot. T, we also run T in our calculator, we get, well, I'll do one of these, so 200 times tangent 53, so I'll clear that out, 200 times tangent of 53. I haven't changed anything about my calculator, it's still on from last time I did these, so I know it's in degrees mode. I type that in, I get 265.41, just so you guys can see it, 200 times tangent of 35 degrees. That was the 140.04. So the next one is 265. Feet. And again, if we know that the top's 265 and we subtract off all that height from the ground up to the bottom, we get the height of the stack. So I'm going to shorthand that 265 minus 140. Please make sure you're using the decimals when you do that. Again, I'm just shorthanding it for the video here. So S is the height of the stack is 125.37. Always make sure you have the right units. Make sure we're answering the question. The question was find the height of the stack. We did that. We are good to go. Let's see. Let's do another problem in this video, and we'll probably just call that good. I'm going to skip 4. It's a very straightforward problem of an angle of depression and a height of a lighthouse. So number 5, I'm going to set up the drawing, because again, we read it, we check to see what we're going for, and then we draw the picture. In this case, my picture I'm going to depict as such. So there's our water. The shallow end is going to start there, and we know that from the height of the water to the bottom, shallow end is 1.3 meters, and the deep end is 4 meters. So what the question's asking is finding what angle is this, because we also know that the width of our pool is 20 meters. So across a 20-meter span, we start at 1.3 meters and we go down as far as 4 meters deep. And what they're asking for is what is this angle in this case. So what we know is 4 goes all the way to the top, all the way to the bottom. If I redraw my triangle that I'm working with, here's my angle that I want to know, and I know that this width is 20 meters. What I need to do here is say 4 minus 1.3. And that is the triangle we're solving. So if you do that math, it's like 2.7, I think. So what we have, again, we have opposite and adjacent. So we have tangent theta equals 2.7 over 20. To get theta by itself, we take the tangent inverse of tangent of theta. What we do to one side, we do to the other. And we find theta is equal to 7.69. As long as we have labeled that correctly in our diagram, we can call that good. Find the angle of the bottom of the pool. Sometimes, like in this case, you might call it 97.69 degrees. And the reason is, if you were to start at the vertical and work your way all the way down, that's 90 degrees to horizontal plus the 7. But anyways, I digress. Number 6, let's see. I'll save 6. I'll do 6 and 7 in the next video.